Good morning, everyone. Thanks for joining another live stream from Fluid Numerics. I'm Joe Schoonover, and today we're going to be talking about some strategies for managing your HPC resources on Google Cloud. So let's go ahead and just get started. Want to cover what we're going to be doing today. So the first thing on the agenda is to show you how you can deploy an auto-scaling HPC cluster with a slurm job scheduler using Terraform infrastructure as code. We've provided some resources out there on Github that have a few examples that should help you get started pretty quickly. So we'll walk through that. And I'll kind of illustrate as we're setting up that your first project here, how we're going to actually do the plans and deploys, and then how to encode that into Google Cloud build steps. And then we'll get to the point where we're setting up basic dev and prod triggers using Cloud Build and Google Source Repository. So that by the end of today, you should have a very basic pipeline that can help you as a team of system administrators or folks who are just managing HPC clusters on the cloud over the course of a few months or years to really get into this sort of continuous integration, continuous deployment strategy for maintaining your resources. So the idea being that you would have your team sitting on one side receiving issues and feature requests. Maybe you have folks who are asking for different machine types, different packages to be available on your cluster. You want to be able to basically go as a team and commit those changes to a repository, say to a dev branch, and have that automatically trigger off Terraform plans, perhaps changes to virtual machine images and all those types of things. And then after an accumulation of a certain number of changes, again, you guys can get to a review stage where you can review everything that's coming in from Terraform. And then decide what types of things you want to merge in to a main branch and have that automatically trigger the application of all those changes you guys decided on. So let's just go ahead and dive in. First, I guess I do want to share with you the repository we're going to be using today is the Fluid Slurm GCP Terraform repo. It has an example deployment on there. Go ahead and pull this up on my screen. There we are. We're going to be using this CentOS cluster example here to get started. Basically what we're going to be doing is copying that out from this repository and setting up your own GSR using this as a good starting point. So if you want to go ahead and head on over to console.cloud.google.com, we're going to go ahead and hop into the Cloud Shell, which you can find up in the top right corner. Let's pop that into a new window. Once that loads, go ahead and set your project using gcloud config, set project. Here we're going to be doing cloud HPC demo, and we'll start by setting up a new directory. Today, let's just call that demo. Okay, and then inside of there, let's go ahead and clone this repository, and then we'll pull out that directory for the example. Whoops, we need git clone. All right, so if we go inside there, oops, no, I don't want to go inside there. What I want to do is make a new directory for my for the new cluster that I want to be deploying here with Terraform. So let's call it, I don't know, my HPC cluster. So then we'll copy recursively everything underneath the Fluid Slurm GCP examples for the CentOS cluster. My HPC cluster, there we go. All right. So underneath here, there's a few things. You get the basic scaffolding for a Terraform project. I mean, really, it's just this main.tf, which has all the declarations of the resources we want to create. And this is going to include everything from identity and access management policies. We have networking, firewall rules, and service accounts. And of course, you have the controller and login nodes that are going to be used for your cluster. Now, in addition to that, all the rest of the things we're going to be setting up today, particularly the build triggers and some of this other initial setup, you can encode in Terraform, but I did want to show you through the console how to do that so you have a really good idea of what's actually being set up here. So the first thing you're going to want to do once you're here is go ahead and edit that fluid.auto.tf vars. This is the file that's going to allow you to concretize some of the variables we've exposed for you to customize that deployment for your organization. So in the cluster name, this is the string that's going to be prepending your login node and your controller. I'll just call it my HPC cluster. So what I'll end up deploying today is my HPC cluster login and my HPC cluster controller, and then of course networks and subnets that go with that. You'll need to set the project ID where you want to deploy everything. For me, that's Cloud HPC Demo. Of course, for you, that's going to be a different GCP project ID. And the zone, of course, where you want to deploy all that. I'm just going to go ahead and set that to US West 1B. Think about where you want to deploy that zone. That's also going to depend on where you might have other file servers like Lustre or File Store. And of course, if you're on your compute partitions, if you need to use GPUs or any of those special machine types, make sure those are available in the zone you choose. Now down here on the partitions, we've set this up to where you can pretty much leave everything as is except for that zone. You do need to fill that in. So we'll go ahead and fill that in as well. Just leave everything in US West 1B. Now the cool thing about infrastructure as code is we can change this at any time down the line just by coming in here and making these changes. And of course, by the end of today, in the next 15 to 30 minutes here, you'll see how you can do that just by making this change and committing it to your repository. Okay, so down below we've got some sort of like user management controls here. So we have you know, when you run an HPC cluster, we generally think of two groups of people. We have the system administrators, the people who are managing those resources, perhaps providing packages and things like that that need to be made available for researchers. So we have the admins up top and the users down below. Now we actually like to use cloud identity groups to kind of group people into these different categories to make it nice and easy so you don't have to write out all the email addresses. But if you're not doing that, that's okay. Up here, so at Fluid Numerics, for example, we have a team called support, and that includes a number of folks. So all I have to do is set group support at fluidnumerics.com. Now again, if you do have multiple groups or multiple users, you would just add a comma separated list here. Down on the users, we're basically doing the same thing, and since today I'm going to be the only one on this cluster, I'm just going to go ahead and set this to Joe at fluidnumerics.com. Of course, again, if you have multiple folks you want to have access to this cluster, this is where you add them here. What this is going to do is it's going to set up identity and access management policies for these two groups. The admins are going to get compute OS login admin, service account user, and a few other permissions that allow them to control things on the GCP panel. The users are just going to get the compute OS login and the service account user simply just so that they can SSH into the cluster and carry out their business. Down below, now if you are planning on using the cluster services CLI that's on all of our images to manage your slurm accounts, you can set the slurm accounts block here. This will get copied onto instance metadata for the controller and then passed into the cluster upon deployment so that the slurm accounts can actually be generated for you. Now, if you're not using the slurm accounts for cluster services, that's okay too. If you want to use the S account manager tools, if you did want to do that, just go ahead and leave that blank like I've just shown there above. Otherwise, we can go ahead and fill this in. So the name I'm just going to use for today is demo account. The users, you need to provide a comma separated list of all the POSIX user accounts that are going to be submitting jobs on that cluster. And of course, the allowed partitions. If you're curious of what should be going here, well, if you look up in your partitions settings here, the name field for each partition is what's going to be the allowable values to set here for the allowed partitions. Today we only have one. It's called demo, so we'll just leave this as demo. So that should be it. Let's kind of do the first initial setup here to allow us to use Terraform. So if I do Terraform init, this is going to set up all the providers for us. Of course, I've got an issue with, let's see here. Let me go ahead and fix that real fast. Looks like I have an issue. I pushed up a fix last night. You should never do this before a live stream. Let me go ahead and fix that real quick. Just go ahead and give me 1 second here. All right, sorry about that. So we're back. I just had, I got a patch I'm pushing up there. At any rate, once you run that Terraform init, you should see this statement down below. Terraform's been successfully initialized. And next thing we're gonna do is run a Terraform plan. All right, so basically the Terraform plan provides you a statement of everything that's about to be created. And like I said before, this includes everything from service accounts, identity and access management policies, networking resources, and those compute resources for us. Now, basically what we would do from here if we wanted to actually deploy all these changes in our project to actually create those resources, we would just run a Terraform apply. And I'm going to run with the auto approve flag just so we can bypass the approval process here. Of course, at this point, usually what you would do is review that plan if you're doing this just from the command line, of course, on your own. But as you'll see, once we get into Google Cloud Build, you'll be reviewing that plan as a team. So we'll run that Terraform apply with the auto approve. And basically, this is going to set up a whole bunch of stuff for us. It's going to take a few minutes. While that's happening, let's go ahead and set up some of the resources we need for Google Cloud Build to be able to execute these commands for us. So the first thing we need to do is head on over to onto the Google Cloud console. Let's drop into that products and services menu and head on down to APIs and services. We have two APIs that we need to enable. The first is the Cloud Resource Manager API. Okay, and then the second one we're going to need to do is the Identity and Access Management API. So we'll go ahead and hit Enable, and we'll let that go ahead and set up. While that's setting up, we'll go ahead and do the next one. Whoop, I don't want to cancel that. Let's see here. APIs and Services, Dashboard, there we go. Enable APIs, and let's go ahead and pull up the Identity and Access Management and hit Enable. Now, while those are enabling, the next thing we need to do is provide the Cloud Build service account the necessary identity and access management permissions to be able to create and destroy compute resources and networking resources. So we can do that by going into Cloud Build and dropping into Settings. And then on the Compute Engine line, you'll go ahead and change that from disabled to enabled. And then go ahead and grant access to all service accounts, because you're also going to need that service account user role down below. And the last role we need to give it, because this Cloud Build service account is going to be controlling identity and access management policies, we also want to go into the IAM panel. Oops, actually, before we do that, let's go ahead and grab that Cloud Build service account ID. So go back into those settings. We'll grab that service account email address, go ahead and copy it, go into the identity and access management panel, IAM, and we'll add that service account there. And then the role you're going to give it is Project IAM Manager. Whoops. Admin, sorry. There we go. Now we'll hit save. All right, so that should give your Cloud Build service account everything it needs to be able to do these Terraform applies that we're going to be doing today. So the next thing we need to do is, let's see here. We would want to take, all right, so now Cloud Build is actually set up. Let's go back into our console and see how we did here. Looks like all of our resources were added for us. If we hop on over to Compute Engine, you'll see we now have our controller and login node. And now what we want to do is talk about how Google Cloud Build can be used to control these resources. Okay. Now let's say we're at a point where we want to make a change. So for example, if you've seen some of our tutorials in the past, we've shown you how you can create virtual machine images that are compatible with this cluster, so you can offer different applications from time to time, basically by swapping out the images on the compute partitions. So if you look, let's hop in real quick into the variables.tf. There's a whole bunch of variables that are not shown in the auto.tfrs because there's a lot of default values we provide for you. But if you look for that compute image, down below, you see the default is set to this Fluid Slurm GCP Compute CentOS. Let's copy that and go back in that Fluid auto.tfrs. Let's bring this in. And let's say, for example, you wanted to deploy OpenFOAM on this cluster. So what you could do is come here to this end block here. Now, all of our images are hosted on this Fluid Cluster Ops projects. So you see in this this line here for specifying the image. You got projects, Fluid Cluster Ops. That's where all of our stuff's hosted, and the name of the image that we provide for OpenFOAM is OpenFOAM GCP. Okay. And let's say, because we're using OpenFOAM, we want to change the name of this partition to OpenFOAM. And of course, the disk size for this particular image is 50 gigs. So you'll need to up that size there. And instead of running on the N1s, let's go ahead and change this to something a bit more performant like the C2 standards. Cool. Now, of course, at this point, you'd also want to make sure that those C2 standards are also available in that particular zone. I do know that they are available there, so we're actually using them now. But of course, during your review process, you want to check a lot of these boxes, make sure you're not going to run into any hitches when you run that deployment. So in the allowed partitions, we're going to need to change this from demo now to the new partition name. Okay, so let's say that this was a change that was requested for your cluster. Now we've got that in place. What we can do now is run a Terraform plan. And what this will do is it'll compare. You'll notice that there's this terraform.tf state file that's in that home directory. It's essentially a JSON database that lists out all the resources that Terraform is controlling for you. So when you do a Terraform plan, it's going to compare against that. It's also going to compare against what's already deployed in your projects, just to double check that information. And then it's going to basically give you a list of changes that are going to happen. And right now, if you scroll down to the bottom, you'll get a summary. We got 2 to change, 0 to add, 0 to destroy. And if you were to scroll up and look through, basically searching for those tilde lines there, it'll show you exactly what's going to be changed for you. All right. So Terraform plan, we know, is the thing that we're going to be doing to be generating what's possibly coming down the line before we actually apply those changes. Now in this repository, in this example repo we provided for you, there's 2 directories, dev and main. And underneath those directories are cloud build YAML files that provide some build steps to apply in the dev branch, the Terraform plans. And then of course on the main branch, or in that main directory, we have the steps to actually apply those changes. So let's first look at that dev branch, or that dev directory, cloud build YAML. It's very simple, just one step. It runs through Terraform init. It runs a validate to make sure that everything you're sending it through is of course valid syntax. And then we actually run the Terraform plan. So if you want cloud build to run this, of course we can do this manually. I can run gcloud builds submit dot, and then we can pass it the config of dev cloud build.yaml, and I'm going to run with the async flag so I can show you where you'll see these logs pop up on the Google console. And then what we'll do from here is actually configure a build trigger to run basically this command whenever we push to a branch called dev. So right now it's doing some setup here. Essentially what cloud build does is it's going to bundle up that argument there, the dot, is referring to the directory that we need to bundle up and send up to the cloud build service. So that's what it's doing there. It's got the build queued. So if I go back to that products and services and hit cloud build, you'll see we've got that build coming through. Okay. Now if we expand those logs, what we're going to end up seeing here is the same exact plan that I just showed you on the screen that we ran manually just by hitting Terraform plan. Of course, now this is all being executed by Google Cloud Build service account. All right. Sorry, it's running through the initialization. We're looking good. The validation passed, and now it's just running that Terraform plan. So nothing new except for the fact that this is now running on Google Cloud Build. So let's go ahead and set up a trigger. So if you on the Cloud Build console there on that left side, hit the triggers, and then we'll hit create trigger down below, and then name. Let's call it my HPC cluster dev, and then we'll say make TF plans on push to dev. All right, so we'll say on a push to a branch. Now, we didn't set up a repository, so we need to actually go ahead and do that. So let's do a git status here. Okay. We don't even have the git repository set up. So what we need to do is actually run through a git init. Looks like I skipped a step here. And let's go ahead and add everything we've got underneath the hood. And we will do our first commit. Okay. So the deal is now we need to actually have a repository to use here. So I'm going to leave this in place, and what we'll do is on that products and services menu, hop on over to the source repositories, and let's create a new one. So up in the top right, hit add repository, we'll create new, and we'll go ahead and call it my HPC cluster. Now this is going to provide a central repository that your team can use. It's isolated on GCP, so you can control who has access to it, which is really nice. So what we're going to do is select the option to push from a local Git repository. Now, if you haven't used source repositories before, go ahead and register that SSH key, and then down below, copy that command for adding that remote to this local repository. Because if you check right now, there is no remote for this repository. But what we need to do is go ahead and add that. So that's going to add a remote called Google. So now if I do a git remote -v, here's our Google remote. And then what we want to do is git push -all up to that Google remote. Okay, so now if I look at that source repository, okay, I've got my code up there. So let's go back here and let's refresh this page on the Google Cloud Build side, and we'll refill out that form to get that trigger set up. So we'll say my HPC cluster dev, and again, that description, what we're going to do in this with this trigger is make, boy, things are just jumping around today. Let's go back to those triggers. Nope. Create trigger. My HPC cluster dev. All right, third time. Make TF plan on push to dev. All right. For that source repository, we'll now use that new source repository we made, and then we'll just put the regex statement in there for the branch to filter out only the dev branch. Now the cloud build configuration file we're going to use is going to be dev/cloudbuild.yaml, and we're not using substitution variables in that particular build. So we can go ahead and create. Now what we'll do is we'll make a branch here. So git checkout-b called dev, and then let's push that branch up to the Google remote. So we'll push, you need the -u flag since it's a new branch. And then if we go back to that dashboard, what we should see here any second now, the history, there's our Terraform plan being created for us because we pushed that dev branch, which is really good. Again, if we go to that expanded view, you'll be able to see basically the same thing happening now, but now it was triggered by a push to a branch rather than an individual manually creating that Terraform plan. So there we go. All right, so the next step, let's talk about what needs to happen for the when you want to actually apply those changes. So we don't just want to do just the Terraform plan. Of course, we want to apply those changes, and then there's actually some extra steps we need to do on this cluster to get those changes reflected in slurm. So we got actually two steps for you here. So the first one looks very familiar. It's almost like exactly what we did with the Terraform plan. It's got those same first three steps, except now we add that Terraform apply with the auto approve flag, and then down below we run two commands over SSH on the controller. The first step here, this update config call, what it's doing is actually pulling the cluster config from the instance metadata on the controller and bringing it into the cluster. Okay, and then this next step, the update all, is going to read that new cluster config, basically that's installed on your controller, and actually run through the processes of updating your partitions, your mounts, and your slurm accounts. So that's really it. But you'll notice down below we actually have two substitution variables here. We have the controller variable and then the zone. You'll just need to make sure that these are set to the name of your controller and the zone that the controller is deployed to. So for us, remember, because the cluster is called My HPC Cluster, the controller's name is My HPC Cluster Demo. So let's go ahead and set up that trigger, and we'll go ahead and simulate what would happen, of course, if we push to that main branch. So we'll call this My HPC Cluster main. Okay, we're going to apply changes. Let's see, apply TF plan on changes, on a push to the master branch. Since the default branch on the GSR is a master, that's what we'll leave it at. Again, that source repository, you'll select that repo you just made. Use that master branch, and then that cloud build configuration file. What we're going to need is main/cloudbuild.yaml, and then we'll add two variables. So the first one is controller. Again, that controller name is My HPC Cluster Controller. Okay, and then we have the zone is US West 1B. Okay. Now again, I'm showing you how to do all this manually. Like I said before, you can actually add to that main.tf file in your repository here. All of these build triggers can be added into this main.tf using Terraform, so that you don't have to go through and manually configure this. The last thing we need to do to make sure that everyone sees the same backend. There was one thing I kind of snuck in here. So when we ran that Google Cloud build the first time, it brought up this terraform.tf state, so it knew what the actual state was going to be. And right now, that terraform.tf state is stuck in the Git repository, which can sometimes cause issues. So what I recommend to do is actually we're going to do a git rm on that terraform.tf state. Okay, and then instead, actually, you know what? Let's bring that back in real quick so that we can get the backend set up. Whoops, got that backwards. So do git checkout ahead. There we go. All right, so what we first need to do here, so right now, let's back up here. Right now, what we have is the terraform.tf state. Again, is that JSON database that stores all the resources that Terraform is modifying. What we want to do is get that file out of the Git repository and actually push it up to a GCS backend. So that it's in a separate location where there's less potential for conflicts when you have different folks all touching the same repository. So what we want to do is in that main.tf, we've left a block here for you between lines 2 and 9. You can go ahead and uncomment that now. And what we need to do is set up a GCS bucket that we want to use here. So I'm going to actually just remove that prefix. Let's go back to the Cloud Console, we'll go to Home, scroll on down to Storage. If you don't already have a bucket set up, that's okay. We'll actually walk through setting one up today. So for the bucket name here, let's call it TF, my HPC cluster. So Terraform, and of course, make sure you spend some time looking through all these possible options here. Every single one of these affects the I guess how distributed some of that data is, and of course your cost down the line. I am going to go through and accept a lot of the defaults, except change the access controls to uniform, and we'll go ahead and create. Now that bucket name is what we're going to need to copy, so that's TF my HPC cluster, and that's what we're going to put in here. And then we're going to rerun the Terraform init so we can migrate that terraform.tf state up to the GCS bucket. Okay. Okay. So now it's basically asking if we want to copy the existing state to the new backend. We'll go ahead and say yes. So now if I go back to that bucket, you'll see that Terraform TF state file is now up in that GCS bucket. So we're good there. And let's go ahead and add that main.tf, and now let's go ahead and remove that terraform.tf state. Okay, so that's all okay. And let's commit switch to GCS backend. Okay, and remember we're on the dev branch, so again, if I push that dev branch, I should see the same exact plan come back through. But again, on that cloud build panel, that build's happening for us. So the next thing we want to do, of course, is let's say you guys have reviewed your plan and you're ready to accept it and you want to apply it. All you need to do is git checkout that master branch or the main branch, whatever you have configured as that production branch that you're going to be using. We'll git merge with dev. And then you'll push, git push Google. Okay, now this last step here, that whole checkout, the merge process, of course, I did it manually here. Usually in these more automated environments, what you might have is some type of endpoint set up where you guys can actually carry out your review process. And of course, once all reviews are in, you can automatically trigger through a cloud function or cloud runs to handle that git merge for you, and of course pushing that back to the cloud source repository. Let's go back to that build history real quick. In just about any second now, we'll see that, oh, actually there it is. The master build is actually going through. But that's really it for today. So I hope you guys found this useful. Thank you for joining me and bearing with me through a few of those mistakes this morning, and we hope to catch you next time. Thanks again.